This is a Math 2 lesson summary video for the task titled It All Adds Up. This is a Develop Understanding task. The purpose of this lesson is for students to add and subtract polynomials. Before we start adding and subtracting polynomials, let's go over some key vocabulary. So a polynomial is an expression that can be written as the sum or difference of polynomial terms. And a polynomial term is an expression that can be written as ax to the b power, where b is a whole number. So what I'm talking about here with a polynomial is we can have, for example, 5x to the third plus 2x squared plus 4x minus 1. This polynomial expression has 4 terms, 1, 2, 3, 4. Each term is written in this form, even this constant right here. So -1 can be written in this form by saying -1x to the 0 power, because anything to the 0 power is 1. So this evaluates to -1. So a monomial is a polynomial with one term, such as 5x or 3 or -2x squared. A binomial is a polynomial with two terms. For example, x plus 2, but binomials could also be x squared minus 4, or any polynomial that has two terms. Like terms have the same degree, so this will come in handy when we are combining like terms when we're adding and subtracting our polynomials later in this video. For example, -2x squared and 3x squared are like terms. If I add them together, I would get 1x squared. So as you can see in this example, like terms not only have the same degree, but they have the same variables with exponents. The degree of the term is the sum of the exponents in the term. So if my term is 12x to the 5th power, my degree is 5. If my term had 3x squared y, the degree would be 3 because I do 2 plus 1. The degree of a polynomial is the largest degree of a term within the polynomial. So for example, if we look at this polynomial here, the degree of the polynomial is 3 because this term has a degree of 3, this term has a degree of 2, this term has a degree of 1, this last term has a degree of 0. 3 is the largest degree, so this polynomial has a degree equal to 3. A constant is an expression that can be written as ax to the b power, where b equals 0. In other words, a number. So 10 is a constant. -5 is a constant. The square root of 2 is a constant. A coefficient in the expression ax to the b power, a is the coefficient. So in the expression 5x to the 3rd power, 5 is the coefficient. And this term has a degree of 3. When we write polynomials, we write them so that the terms are in descending order. That means that the highest degree term is listed first, followed by the next highest degree, then the next, leaving the term with the smallest degree as the last term. So if we were given a polynomial, we would list these terms in descending order by starting with the term with the highest degree. That would be this one right here because it has a degree of 4. I would list that as -50x to the 4th. Then I would move on to the next highest degree, so -5x to the 3rd, then plus 3x squared, then plus 2x, and then finally plus 6. When the terms of a polynomial are listed in descending order, the leading coefficient is listed first. So for this polynomial example, -50 is the leading coefficient. All right, let's start adding polynomials. I want to show you two different strategies for organizing your polynomials when you add them. So in number 5 here, I'm going to add h of x plus k of x. So h of x is right here, and then here's k of x. So we're going to add those two polynomials. I'm going to stack them on top of each other. So now I have 2x squared minus an x squared, which leaves me with 1x squared. 5x minus 3x leaves me with a positive 2x. And then negative 12 plus 4 gives me negative 8, which I'll write as minus 8. For c, I'm going to add f of x plus k of x. This time I'm going to use the strategy where I list the polynomials beside each other. Now I want to find like terms. So 3x squared and negative x squared, those are like terms because they both have x squared. Negative 2x and negative 3x are like terms because they both just have an x. And then the constants plus 10 and plus 4 are like terms. Now I can bring down my x to the third power and then add 3x squared plus negative x. So 3 plus a negative 1 is positive 2x squared. So negative 2x plus negative 3x, or negative 2x minus 3x, whichever way you want to think about it, will make negative 5x. So I'll write that as minus 5x. And then 10 plus 4 is 14. Now let's look at a couple of examples of subtraction. So we're subtracting these two polynomials. And this first example shows how you can maintain listing them side by side, except they changed this to a plus and they distributed this negative to each term. So they multiplied negative 1 into the second set of parentheses and then changed this to plus. By doing this, now they can just look at like terms. They have x to the third plus negative 2x to the third, which gave them minus x to the third. They had a positive x squared plus x squared, giving them 2x squared. Negative 3x plus negative 6x makes a negative 9x, and then negative 5 plus negative 8 is negative 13. Or you can line them up vertically, like they did here. Again, they still changed it to plus and have all of the signs opposite that they were originally. And then they just add down. Let's do a couple more examples. For 10a, we have h of x minus k of x. Let's list these side by side. So I'm going to distribute this negative. And the math that I'm doing, remember, is just multiplying by a negative 1. So that's going to make this plus x squared minus 7x minus 4. Now when I'm adding, I can just look at like terms. 4x squared plus x squared is 5x squared. Negative x plus negative 7x is a negative 8x. And then negative 15 plus negative 4 makes negative 19. So we have our answer, 5x squared minus 8x minus 19. Now let's subtract. We'll do f of x minus g of x. So to get started, I'm going to list this as x to the third plus 2x squared minus 7x minus 8 minus negative 4x minus 7. I'm going to rewrite this as an addition problem. I'm going to show you how you can stack the expressions. So I'm going to list the first one here, and then I'm adding 4x plus 7. So I want to make sure that I line them up so they're with like terms. That gives me x to the third plus 2x squared, negative 3x, negative 8 plus 7 is negative 1. And there's our answer, x cubed plus 2x squared minus 3x minus 1. All right, that's it for this video. Thank you for watching.